Okay, Lamai, good evening. Today we are discussing questions from MCQ 7 in our monthly test paper, which was given to you on April. Okay, April monthly test paper 2027 A-level. Okay, so last paper class we did 6 MCQs, so we will continue from the remaining MCQs. Okay, so the marking scheme of the paper was added to your group on this last Sunday. I hope you all went through that one. And the remaining, your marks will be all given within this week. And we're going to complete the task on this paper. Okay. So here, yeah. So let's start our discussion from this 7th MCQ. Okay. And try to write a good review. When necessary, give it in details. But for the questions that you're already comfortable with, write a small review. Okay, so if you're having any doubts other than the explanation that I'm giving you, please ask them. Okay, look at the first one. Which one of the following statement is true with regard to inorganic elements and compounds? Look at the first statement. When H2S gas is tested with filter paper moist with cadmium acetate, the filter paper turns to black. Okay, this statement is Lamai false. To identify H2S, how many tests are there? To identify H2S, there are 4 tests. You can test it with lead acetate. Lead acetate. Acetate means CH3COO. So, since the lead valence is 2, you need 2 acetate ions. So, this is lead acetate. Or you can add lead nitrate also. PbNO3 twice. So what we need is Lamai. This anion should not be precipitated with lead. So you know from solubility rules, nitrates, acetates, they are not going to make any precipitate with any ion, any cation. So they are very good to use with lead. So lead acetate or lead nitrate, when you add that one with H2S, it will form the sulfur. So PbS is black color sulfur. So you can use cadmium acetate also. So, but when you use cadmium acetate or cadmium nitrate, whatever, you will get cadmium sulfur. The thing is, it is not black color. What is the color of that one? It is a yellow color PPT. So that's why the first statement is wrong. So there are 2 other tests for identifying H2S. So you can add those reactions to your review. Balanced chemical equations would be better. So you can test that one with acidic potassium permanganate, or you can test that one with acidic potassium dichromate. Okay. So when you test that one with potassium permanganate, you will get a yellow turbidity. Purple color turns to yellow turbidity. When you test that one with potassium dichromate, the orange color of the dichromate will turn to yellowish green turbidity. So for what I am asking you to do, write the balanced chemical equations for these 2 reactions. It's very important. So like that, when you are doing a question review, like we said this one before several times, you can automatically remember all the theory areas. So please do it. And if you didn't do any of these work for like few months, let's say you did work from the beginning and for some reason you forgot or you couldn't keep up with the task, the paper class. So start now. Start from this paper. Even from this MCQ, 7th MCQ, it is enough lang. Hari patanga. Okay. So like I asked, complete the review for this first statement. Now let's go to the next one. So we are seeking for the correct statement. In the second statement, it is telling silver iodide dissolve in conch ammonium hydroxide to give a colorless solution. So that is also wrong. Why? Because silver iodide, so silver halides, there are 3 silver halides now. AgCl, AgBr and AgI. Okay, so these are precipitates. So this is a white color precipitate. This is a pale yellow precipitate. This is a yellow color precipitate. They all are precipitates. Understand? So these things are there is a confirmation test for these three precipitates, because the thing is the white color and pale yellow color somewhat difficult to determine which color is that. Okay, so in that case we have an alternative method. We have a confirmation test. So that confirmation is done by adding ammonium hydroxide, or you can say ammonia, aqueous ammonia. So the thing is, if you add aqueous ammonia, it may be dilute or conc, no problem. Dilute or conc ammonia, or you can say ammonium hydroxide, ammonia AQ, or ammonium hydroxide, whatever the thing is correct only. And it will dissolve to give diamine complex. Diamine complex, it will form this complex cation, and it will be paired with chlorine. So this is the compound that is going to result. But the interesting thing is, Pute, this is colorless. Colorless. Okay. So the pale yellow precipitate, AgBr, will dissolve only with conc ammonium hydroxide or ammonia only. Okay. So it will form again the same diamine complex. Okay. Now the counter anion is Br. This is also colorless. Both are colorless aqueous solutions. Right? But when you add dilute ammonia, it will not dissolve. And silver iodide. Now I hope you remember the rest. If you add even dilute ammonium hydroxide or the other one, or if you add conc ammonium hydroxide, whatever you are adding, it's not going to dissolve. Okay, so here it is telling it will dissolve with conc ammonium hydroxide. It is wrong. Okay, it's not going to dissolve with any ammonium hydroxide. Okay, ammonium hydroxide or ammonia is not going to dissolve. Then check the third statement. Third statement. In third statement, it is telling the solubility of hydroxides of group 2 metals in water increases down descending the group, while the solubility of sulfates increases. The solubility of hydroxides of group 2 metals in water increases. Solubility of hydroxides, while the solubility of their sulfates increases. Increases, right? That statement is, again, yeah, that statement is also wrong. I think solubility of hydroxides downward the group 2 metals in water increases on descending the group. That part is correct. While their sulfate, the solubility of their sulfates not increases, it should be decreases. Ne? Here actually you don't have any answer either. This statement is also wrong. In my marking scheme that I provided you, I got it as correct, but actually it is also wrong. Hydroxide solubility increases. You remember this chart from our solubility rules, Lama? Magnesium 2 plus, calcium 2 plus, strontium 2 plus, and barium 2 plus. Right? And hydroxide solubility. Hydroxide solubility. Okay, so it was mentioned by the arrows. Here you had 3 arrows. That means it is a very good precipitate. But downward the group, the solubility increases. So barium hydroxide is completely soluble. Soluble. But when it comes to sulfates, all the order is changed. Order is changed. For sulfate solubility, downward the group it decreases. Solubility decreases, precipitation ability increases. Now magnesium sulfate is a good solution, soluble. But this one is a precipitate, this one is a somewhat better precipitate. But barium sulfate is a very good precipitate. So remember this point, it is a very common MCQ point. But however, it is taken as a wrong answer here. Okay, solubility of group 2 hydroxides increases in water, while the solubility of their sulfates increases. That part is wrong. The last increases is wrong. Okay, lah. Anyway, take it as a wrong statement. Now let's say why fourth and fifth answers are also wrong. Anyway, there's no answer for this question. Answer 5. No, answer all. Answer all. Among the group 1 metals, lithium shows highest reactivity with oxygen. That is wrong, Pute. You can simply write in S block or group 1, group 2, reactivity increases downward. Reactivity increases downward. So the lithium that they tell us here, lithium is a group 1 metal and it is there at the top of the group 1. So that means it has the least reactivity from group, not the highest reactivity. It is least reactivity. And look at the last statement. Among the group 2 metals, magnesium has the highest melting point. Magnesium has the highest melting point. That one is again wrong. If you take group 2 metals, it is starting from beryllium. Beryllium, magnesium, then you have calcium, strontium, and barium. These are the 5 metals. So their melting point decreases. Melting point decreases downward. Okay, so the highest melting point is therefore not magnesium. It is therefore beryllium. So why beryllium is having a higher melting point? The reason is melting point depends on lamai 3 things: charge, size, and number of free electrons. So number of free electrons, charge, they are same. So this one is the one with the smaller metal ion size. Size of the metal ion is low. Okay, so therefore more metallic bonds in unit volume. That's why beryllium is having the highest melting point. Okay, Laman, so all the statements are wrong. So answer for the 7th one is all. Okay, when I'm giving you the papers, I'll change it and give you. Right, so that is the explanation of the 7th MCQ. Yes, next one is about energetics. Which of the following is correct with regard to the reaction given below under standard conditions? So in that reaction, Lamai, there are two halves given. First one is A reacts with 3B to form 2C. They all are gases. And then 3D gas reacting to form C. And the enthalpy changes are given. Delta H1, 2. So these are standard enthalpies as the question says. First one is minus 218. And the other one is plus 74. These are the two enthalpy changes. So now what are the statements they ask? Look at the first one. For 1 mole of the first reaction, 218 of heat is absorbed. Okay, so that statement is wrong, Lama. It's not absorbed. So minus sign implicate Lama exothermic. So 218 kilojoules of heat is not absorbed. It is released. Okay, I'll explain all the statements at once. So you can say 218 kilojoules is released. So this minus sign implicate it is exothermic. So release energy. First one is wrong. If you go to the second statement, it says, for the reaction A plus 3B goes to 6D. Now, such reaction is not there, but we can form it. So how do we form it, Lama? You can add these two reactions and see. So now let's give it a try. Let's label them as 1 and 2. So now we can see the equation they are asking doesn't contain any C. Okay, so to cancel C, what you should do? Add the first reaction first reaction to the second one after reversing the second one and multiplying by 2. Okay, so I'll show it how it is happening. Now you have A plus 3B goes to 2C. Then if you reverse the second equation and multiply by 2, it becomes 2C goes to 6B. Now same thing happens to enthalpy change, okay? This one is minus 144. Because you reverse and multiply by 2. And now you can see 2C get cancelled. You get that A plus 3B goes to 6D reaction. And enthalpy change is sum of these two. Okay, it will be 12, 1, 6, minus 362. That is the enthalpy change, exothermic. But the question is telling a positive answer. So even without simplifying, you can tell that the statement is wrong. It is not going to be positive. No? It's not positive. I mean, they are telling released. So that means it is exothermic. But however, that energy is not 70. You can see it is more than 218 even. So this you can think and get this answer also. Then my third one, no need to simplify. Anyway, second one, no need to simplify. Anyway, second one is wrong. Now let's go to the third state. It says for 1 mole of C produced in the first reaction, 109 kilojoules of heat is evolved. Now in the first reaction, you can see Pute, 2 C is produced. But if you want it for 1 C, what you should do? Divide this equation by 2. Then you will get C. Then same thing will happen to your enthalpy change. Minus 218 is divided by 2. So then it will become minus 109. So that means released. So that part is correct, no? That part is correct. So your third statement is correct. That is your answer. Okay, Lamai. Now let's see why fourth and fifth are wrong. Fourth statement tells for the reaction 2C goes to 6D. Now that means you have reversed and multiplied by 2. Okay. So the enthalpy change is minus 148. This is a small mistake. So it is 16. Okay. So minus 148. That is the answer. So it is not endothermic, exothermic. So that's why fourth statement is wrong. Now let's see why the fifth one is wrong. For 1 mole of C producing the second reaction. Yeah, you can see it's already 1. 74 heat is released now. It is plus 74. So that one is endothermic. Absorb heat. Understood? So fifth statement is also wrong. It is a good question, by the way, which is checking your basic knowledge about thermochemical equation. Remember, thermochemical equation, we can do several manipulations. We can multiply that equation, reverse that equation, we can add those several equations. So just think what is happening there, and not only that, think about what is meant by thermochemical equation. So when it say minus 218, you need to know what is it giving you, what's the idea. Okay, so that everything is checked in this MCQ. That is a very good MCQ for you to practice. Okay, Lama. Now, answer is answer 3. Now let's go to the next MCQ, question number 9. Question number 9. It is asking about ideal gases. Ideal gases. ideal gases. Which of the following statements most appropriately explain why a real gas tend to behave as an ideal gas at high temperature and low pressure? So yes, real gases attain the ideal behavior. Okay, they don't become ideal, but they behave like ideal at high temperature and low pressure. So what is the reason? Okay, first of all, before going into these statements, we will casually explain why real gases try to behave as ideal at that conditions. Question number 9. Okay, so what is happening at high temperature? What is happening at high temperature? So at high temperature, kinetic energy of molecules is getting higher. Therefore, intermolecular attractions are weakened. Okay, so then it behave like ideal because ideal gases are having no intermolecular attractions. So when real gases weaken their intermolecular attractions, they can reach the ideal behavior, behave like ideal, not become ideal. They never say become ideal. They can behave like ideal. Okay, and the next thing is at low pressure. Low pressure. This is kind of tricky to understand. First of all, for understanding how it is becoming, how it is behaving like ideal, you need to understand how do we make low pressure. So low pressure is achieved by two ways. Either you can remove gas, remove some amount of gas, or there's another way, you can increase the volume of the content. Okay, volume of content. By doing these two things, you can achieve a low pressure. Understand now? You can achieve a low pressure. Okay? So when you remove the gases, when you increase the volume, two things can happen. First one is intermolecular distance. Intermolecular distance getting higher. Okay, now let's say in this container, let's say there were 3 molecules, but if you remove one, now the distance is higher, no? Isn't it? Like the distance is getting higher. So because of that, what will happen? Intermolecular attractions are weakened. Then it can reach ideal behavior. And the other thing, Rama, when you increase the volume, can you see what has happened? Now, again, the distance increases, same thing can happen. And another thing can be understood, no, Rama? So when you put those 3 molecules here, the volume that they take from the container is negligible. Here also, when 2 molecules take some volume, it is negligible when compared to the volume that 3 molecules are taking. So the second point that happens, in both cases it happens. Both cases, intermolecular distances are increasing. And in both cases, volume taken by the gas is decreased. Okay. Volume taken by gas molecules itself, that one decreases. Okay, so therefore their size become negligible when compared to container, to volume of container. This is another characteristic of an ideal gas. In an ideal gas, their interparticle distance is very high and their volume is negligible when compared to the size of the content. So that happens for real gases also when you remove some gases and when you increase the volume of the content. So this is the full idea. This is the full theory. So now you need to think which answer is correctly presenting at least one of these reasons. Go to the ninth statement, ninth question and see Lam. First one says intermolecular attractions become stronger. That doesn't happen. Intermolecular attractions become weaker as you increase the temperature and lowering the pressure. That's wrong. The fraction of molecules that move at the most probable speed decreases. Once you increase the temperature, that happens, most probable speed, that curve changes, but that is not affecting the ideal behavior. That's my point. Understand, it is true, second statement is true, but not relevant. But not relevant. Now, at low temperature, this is the curve. At high temperature, this is the curve. T1, T2. You know this one. T2 is greater. And you can see the fraction has now decreased. That is true, but it's not explaining why it behave like ideal. It's not enough. Because anyway, these graphs are drawn for ideal. So it's not explaining the real behavior, real gases, how they behave like ideal. So second one is not relevant. Volume of the gas molecule become negligible when compared to the distance among molecules. Yes, that happens. That is the one that I wrote it in red color. Okay, same meaning, same idea. So third one is correct. That is our answer. Now go to the next one. Why? Let's say why those statements are wrong. Okay? Gas particles do not move random. That's wrong. They do move in random straight line directions. Okay, so we can't say it is no. So do not move part is wrong. And the fifth one is telling about compressibility factor. Compressibility factor, it doesn't approach zero. You remember this compressibility factor graph? It is also a good explanation. Is it compressibility factor against pressure? Okay. For an ideal gas, compressibility factor is 1. And for a real gas llama, it can show two different behaviors, either this one or this one. Both are for real gases. Okay, for gases like hydrogen, helium shows this behavior even at room temperature. Okay. So you can understand now, as you decrease the pressure, what will happen? It will go more closer to the ideal behavior. So I told you during the class, remember, 1 atm is just very near this zero value. So that means under 1 atm pressure, almost any real gas, it behave like ideal. Understand? So, but this statement is anyway true. But they are telling is real gases, they approach zero. It doesn't approach zero, it is approaching 1. Because 1 is the value responsible for ideal gases. Okay. So simply what is it? Z is the compressibility factor. Volume of the real gas divided by volume of the molar volume of the ideal gas. Real Vm real over Vm ideal. Okay, so molar volumes are becoming kind of similar. So when they are similar, they simplify to give 1. When these two are equal, it gives you 1, not 0. So it's wrong. Okay, so that's why each statement is wrong and why the third statement is correct. Hope you understand that one properly. And the next question is Pute also from gases. It's a small calculation related question. I'll explain that. Two identical closed rigid vessels contain 1 mole of H2 and 2 moles of helium at T temperature and 2T Kelvin temperature respectively. So they are at 2 different temperatures. Which of the following is true about the two systems? Okay, now let's see what is going to be the correct answer for the 10th MCQ. It says about two containers, two identical. So here you have H2, 1 mole at T temperature. And in the next container you have helium, 2 moles, and at 2T temperature. So it says first statement, both hydrogen and helium have the same average kinetic energy. You know, Lamai, that is wrong. Okay, why? Because the average kinetic energy, K bar, is directly proportional to absolute temperature. So now you can see the absolute temperatures are different. So their kinetic energies are not going to be equal. Instead of that, you can tell what is the relationship between, in your review, average kinetic energy of hydrogen is, you have to multiply by 2 to get the average kinetic energy of helium, because helium is at a higher temperature, exactly twice. No? So then this is the relationship between their average kinetic energies. Understood, Lam? So it's not same. Then go to the second statement. Second statement tells mean square speed of helium is twice the mean square speed of hydrogen. Mean square speed. So whatever the speed that we need will be directly proportional to T over capital M root. T over capital M root. Now let's apply that one for, it's telling about mean square speed. Ne? So now this is a square speed. Ne? So this is relevant for C square bar root, or we say it as CRMS. CRMS is 3RT over capital M root. But now they are telling us about C square bar, mean square speed. So that will be proportional to T over capital M root, T over capital M. Okay. So now it's not only depends on temperature, it's depending on mass also. Now what they are telling is hydrogen, helium has a twice higher value. It's true that temperature of helium is higher, but the mass of helium is also higher. Molar mass will also affect. Now let's, anyway, that one is wrong. You can understand it clearly. But anyway, let's put it into practice. So C square bar of hydrogen divided by C square bar of helium. Okay. So temperature of hydrogen is T. T over 1, sorry, T over 2. 2 is the relative molecular mass. No, so actually you have to add 2 into 10 to the power minus 3 mole per, sorry, gram per mole, kilogram per mole. But this is an MCQ, no? So let's do it like this. Well, anyway, just write it. Okay, no issue. And then this one, it's at 2T temperature, and it is 4 into 10 to the power minus 3. And it will be simplified to give you T over 2. So that means their mean square speeds are equal, and their mean square root speeds will also be equal. Understood? So at these circumstances, speeds are not different. Any speed level, it may be root mean square speed, most probability speed, average speed, anything will be equal because they simplify to give you 1. And then the second statement is also wrong. Mean square speed is, that is wrong. And then says helium and hydrogen have both same root mean square speed values, that is same. Okay, so I found it for square speed, but if you check the root also, okay, 1 root is again 1. So that is going to be correct. So Lamai, now after doing this calculation, you can easily decide that third one is wrong, fourth one is correct, like that. And look at the fifth statement. Both hydrogen and helium have the same densities. It is wrong, Lamai. Density will be higher. Density will be higher for helium because density is mass over volume. Volumes are same, but since the mass of helium is finally higher than mass of hydrogen because it has more moles also, right? So therefore, density of helium is going to be greater than density of hydrogen. If you follow a mathematical approach, more mathematical approach, you can get the relationship also if you apply it. Okay, this one is 2, this one is 4, and test another 2 here. Then check at home, you will get it. Density of helium is 4 times the density of hydrogen. And add to your review how this is happening. Okay, you have a small exercise to do. Understood, Lamai? So that's our answer. Answer is answer 4. So now you can understand, I hope these questions are not easy, Lamai. These questions are exactly at the exam level. And in your come out with my questions. Okay, so whatever the mark you get, it's okay. And try to use this as a learning opportunity. හරි දැන් මේ ප්‍රශ්න අමාරුනේ ළමයි. අපි මේ දෙන රිවිව් එකම ඔයා හොඳට ස්ටඩි කරලා ඒවා ලියන්න. ලකුණු ගාන ගැන හිතන්න එපා. ලකුණු ගොඩක් තියෙනවා නම් හොඳයි. ටිකක් තියෙනවා නම් දුකයි තමයි. but පාඩ එක වැඩි කරගන්න පුළුවන්. Okay, so think about what you should do to improve your marks and always try to write a good review and study that one. By this single question, Lama, you can remind all the things about the speeds of gases. See? Neither. Now, if you do a paper once a month like this, you can revise automatically all the theory areas. So it will be a good thing. Understood? So use it wisely. And now let's go to the 11th MCQ. It's a chemical calculation, a good one. The answer for this question is going to be answer 3. So actually, I prepared this question few years ago. This will not come to our A-level exam because there are many steps to follow. But anyway, this is a good question for you to practice because it contains limiting reactants, gases, and ARR method, and yeah, limiting reactants. Everything is there. Stoichiometry bridge. So it will be a good exercise for you to do it. Okay, now let's try that question. Question number 11. Okay. First it is telling at 127 Celsius at this volume, O2 is contained in a certain container. So using this data, Lamai, you can find out the moles of O2 using PV equal nRT. So PV over RT, apply it properly and you can get the moles of oxygen. And then it is telling in a separate container you have 1 mole of magnesium and 0.3 moles of N2. So it is telling they are going to react. They're going to react. So then Mg3N2 is formed. And they tells you have 1 mole and 0.3 moles of this. Okay. And then this says the formed Mg3N2. Formed Mg3N2 reacted with excess water. So then you need the reaction between S-block theories are also needed. Water. Then question is anyway telling it is forming magnesium hydroxide and ammonia. In S-block you learn these things. And then the ammonia gas form was added to a container above O2 container. And then it is reacted with O2. NO and H2O. Okay. Then they are asking what is the number of gas moles remaining in the container. It's a good question. Let's see how to do it. Okay, Lama, this is the chart type form. Now let's find out moles of oxygen gas. So pressure is 1.2 into 10 to the power 5 Pascal. And volume is 16.628 into 10 to the power minus 3 meter cube. That's the volume. Then RT 8.314 joule per mole per Kelvin. And temperature is 127 means 400 Kelvin. So now you can see it is easily simplified because it is 2 times. Use a pencil at the exam if it is essay or structured essay. And this one again gets simplified. You can say 0.3 into 2, 0.6, 0.6 moles or 42. That will be important here. Okay, right. Now let's find out how many moles of ammonia is there. For that, you have to come all the way from here. Now, all these reactions are not balanced. Okay, now let's balance them quickly. You can use inspection method to do that one. Here it is balanced. Here it is also balanced. And this one is a little bit tricky to balance, Lama. Okay, now here you have 3 hydrogen, 2 hydrogen. So to balance this one, let's put it like this. In that case, I have to put 2 NO here. All oxygen atoms are here, 5 oxygen atoms. But here you have to divide it into 5 by 2. Okay? So then to remove the fraction, what we should do? Multiply the whole thing by 2. This will become 4. This will become 5. This will become again 4. And this will become 6. They all are gases. Water is also a gas. Okay, so these are the balanced chemical equations. Now you are using ARR, added reacted remaining. So they are reacting in 3:1 ratio. So the limiting reactant is to react with 3, you need 0.33, but you have only 0.3. So limiting reactant is N2. So this whole N2 amount will react, and here 0.9 will react, and 0.1 will be remaining. This is finally completed. And here it will form 0.3 moles of magnesium nitrate. So that 0.3 mole is reacted with excess water. So it will form 0.6 moles of ammonia. Because you can see the ratio 1:6:3:2. So 1:2 ratio. Understood? So then you know from ammonia also you have 0.6 moles. Then let's add added reacted remaining again. Okay. And the ratios are 4:5. 4:6. Now the limiting reactant obviously is going to be oxygen. Okay. So let's say the whole 0.6 is reacted. How many moles of NH3 is reacting? So what you need to do is divide by on stoichiometry 5, multiply by the required stoichiometry 1.2, sorry 0.12, multiply by 4, 0.48. Okay. And here 0.48 is formed. And here 0.12 into 6, 0.72 is formed. Now this one 0.12 is remaining here completed. 0.48 and 0.72 is there. Now to get the final answer, you need to add these 3 moles because this is the final gas amount that remains. 0.12, 0.48 and 0.72. It's given anyway 2, 1. 6 plus 7, you get 13, 1.32 moles. Yeah, 1.32, answer 3. How many of you got that answer? 1.3 to 1.32. Yeah, why one of our student is asking why oxygen is the limiting reactant. So how do we understand that? It's simple, Pute. So think about this one. To react with 5 oxygen, you need 4 ammonia. Okay. So then to react with 10 oxygen, you need 8 ammonia. Like that, continue. Okay. So that means to react with 1 oxygen, you need 0.8 ammonia. Then to react with 6 oxygen, you need multiply this one by 6. 5.6 ammonia. No, it's getting a little bit confused. Ne? So anyway, you multiply this one by 6. And yeah, this is 4.8. 4.8 of ammonia. So then to react with 0.6, you need 0.4. Like that, it is direct proportions. So now you can understand you have more than that from ammonia. That's why ammonia is the excess reactant. O2 is the limiting reactant. So now in the same way, you can work and find out how many moles of O2 will be needed to react 0.6 fully. Okay, so you have to divide by 4. That gives you 0.15 multiply by 5. 0.75 of O2 is needed. So we don't have that much of O2. So that means O2 is the limiting reactant. Now understand? I know. Direct proportionals only. I think you are new with our class, neither. So go through our previous paper class recordings with it. Okay. And send message. I'll send you those recordings of previous paper classes. And you can kind of remind them. Use your time effectively these days. Whatever the theory area that you are uncomfortable with, you can build it from zero. Don't worry. You have time. Okay, now let's go to the 12th MCQ, Lama. I hope there are no more doubts about this question. And it's a good one for your practice on it. In 12th MCQ, it's about again gases. Let's see how to do it. It says there are 2 containers. Okay, so when you open the tap, both gases are allowed to mix with each other. And it says the final pressure is P3 and the final temperature, it's a common temperature. Final temperature is T3. So here you have P1, V1, T1, P2, V2, and T2. So once you open the tap, the whole container becomes 1. And now the V total is V1 plus V2. And you have P3 and T3 total pressures and a common temperature. So it's asking what is the correct expression for T3. What is the correct expression for T3? Now, using this above information, only thing that you don't know is moles. You can find the moles N1. N1 will be P1 V1 over RT. And N2 will be P2 V2 over RT2, isn't it? So once you open the tap, the total moles N total will be N1 plus N2, isn't it? Now, since you know all the information, you know the volume, you know the pressure term, temperature term, and the total mole term. So you can apply this information to your PV equal nRT for the whole setup, isn't it? From that, you can find out T3. Okay, so if you subjected T3, it's going to be PV over nR. PV over NR. So pressure is P3, volume is V1 plus V2. And what is our moles? N1 plus N2? V1 over RT1 plus P2 V2 over RT2. And then R multiplied by R. So you can see now that this R gets cancelled. Ne? So then it is P3 V1 plus V2 divided by now we can get a common denominator P1 V1 T2 plus P1 P2 V2 and T1. Okay, you get the common denominator T1 into T2. So that T1 into T2 you can move up. T1 T2 P3 V1 plus V2. You can expand the brackets also if you want. You can get a bigger expression. But I think we don't need that one. T2 plus P2 V2 T1. So it may be looking confusing at the end, but you can understand the flow, right? And the correct formula is going to be the second one. You can check all the formula given, and you can eliminate one by one. That method will be better, eliminating method. Okay, you can eliminate them one by one. Understood, Lama? You can eliminate. That is method. So answer is answered. So in that answer, they have taken P3 into the bracket. Okay, go to the next question. Question number 13. It is from inorganic chemistry. And it is a good question. We'll see how to do it. The inorganic compound A produces gas B with dilute HCl. Compound A produces the same gas with dilute H2SO4 also, but does not form a clear solution. Now, first of all, Lamai, what is common for dilute HCl and dilute sulfuric is H plus. The common thing is H plus. So now it seems like this compound A should contain something that can release a gas with dilute acids. Okay, you have to touch into that theory part. You get the idea. So now it says A can release the same gas B. A can release the same gas B with both bil HCl and bil sulfuric. No? So that I'm telling you, Lamai, the common thing for both these salts is H plus. Both these acids is H plus. They are releasing H plus. So then whatever this gas is, some gas that release due to H plus. So remember, there are 5 instances that can release gases with dilute acids. Okay. So anions, the theory part is this one. Anions that give gases with dilute acids. Okay, so there are 5 anions. No? What are those 5 anions? CO3 2 minus, SO3 2 minus, S2O3 2 minus, S2O3 2 minus, and S2 minus and NO2 minus. Now, this one is going to give you carbon dioxide than water with H plus. This one is going to give you sulfur dioxide than water. This one gives you a sulfur precipitate, SO2 and water. This one is giving you H2S gas. We discussed that one in the very first question. And this is giving you HNO2. Since it is unstable, later it decomposes to give NO, NO2 and water. So that's the full theory. Now, Lamai, and first it is forming a clear solution with dilute acids. So therefore, we can say this one gives you a clear solution. Because of that, you can say it is not thiosulfate. It is not thiosulfate. Okay. And then it is telling B gas change the color of an acidic potassium dichromate. Okay, so change the color. So that means B gas can undergo oxidation. So that means it is not carbon dioxide. And it says it can produce black precipitate with silver nitrate. So Ag2S is the black PPT. So that one directly tells you what that gas is. Okay, so therefore B must be H2S. H2S gas. So H2S gas can produce these precipitates. Understood? Lead, silver. In cation group analysis, you don't observe silver sulfide because silver was removed in the group 1. But in cation group analysis, group 2, you get lead, bismuth, copper, mercury, lead in black color, and there are several yellow color, orange color, brown color precipitates. And in the group 4 also you get sulfides in basic medium, remember, cosnis, black color, and manganese sulfide pink and zinc sulfide white. So like that, there are several instances. Okay. So with silver nitrate, it is silver sulfide. Okay, remember it as a good point. Okay? Because you don't see silver sulfide in cation group analysis. That's why. So anyway, it is something that contains sulfide. There are only two answers, copper sulfide and barium sulfide. So how do we decide which sulfide is it? That is Pute from this dilute sulfuric. It says it's not a clear solution. It says a white does not form a clear solution. Not clear. So not clear means it should be a white precipitate. So but when you add with barium, it forms barium sulfate, white PPT, white precipitate. Does not form a clear solution. So it's going to give you a precipitate. But someone can argue for this question, can't it be copper also? Because why? If it is copper, at first it will form CuCl2. Okay. And then in the second instant, it is giving you CuSO4. So both are blue color, pale blue. So pale blue aqueous solutions. Understand? But they are same. So the most suitable answer is answer 5 only. Because it says with dilute sulfuric, dilute HCl, it gives produce the same B gas, but dilute sulfuric produces the same B gas, but does not form a clear solution. More weight should be there for this one. The question should be a little bit polished, then it is a very good question. If the question is, the mistakes here is that is telling a clear solution, the Hemanokia, if it is say, it does not give a clear solution, and if you say it is giving you a white precipitate or something, then this question is much better. So if you have the paper with you or to your review, please write Lamai. Instead of does not, so underline does not form clear solution and say, rather than giving this part, telling white precipitate is better. Okay, write that. Rather than giving this part, telling a white precipitate is better. Understood, Lana? Now here it is telling does not form clear solution partner. So instead of giving this part, it is good to tell a white precipitate. Then you can directly easily go to the answer 5. Okay, so anyway, the best answer is answer 5. You can now see these questions are having small, you know, 50-50 doubts and everything. So anyway, these are good questions on the line. So study well. Have something to learn. Now in organic, it's all about remembering equations and remembering, experiments patterns. So I have told you all the things that are necessary to remember in that way. So then use that knowledge and do something only, okay? Right, now let's go to the next question, question number 14. It is asking which one of the following statement regarding S block is incorrect. S block is incorrect. Which one is the following statement regarding S block is incorrect? All the group 2 metals react with nitrogen. That is true, Lam. All group 2 metals are reacting with nitrogen. You can put one example. Example, magnesium react with nitrogen to form magnesium nitride. That is correct. Look at the second statement. Second statement, except lithium and beryllium, all other S block elements react with excess O2 to form their peroxides. That's wrong. So there are many elements. So except lithium, all group 1 metals are forming peroxide. So sodium, potassium, rubidium, cesium. Okay, so they form peroxide. And then from group 2 lamai, it is barium and strontium, strontium and barium. These are the metals that form peroxide. Form peroxides. Understand? So we have other metals. So this is wrong because of magnesium doesn't form, calcium does not form peroxide. So therefore this is wrong. This is our answer. They're asking for the incorrect one. Understood? Then look at the third statement says, their peroxides and superoxide may undergo thermal decomposition. So you are not supposed to learn it, but since the second statement is wrong, you can decide that it is correct. Okay, so let's say a sodium peroxide and let's say potassium superoxide, they undergo thermal decomposition. Okay, so sodium peroxide can give you sodium oxide and O2. This one also can give you potassium oxide or potassium peroxide then O2. O2 gas is liberated by this. Understood? And then fourth one, hydrogen carbonates of lithium. That means lithium bicarbonate. Hydrogen carbonate is bicarbonate, LiHCO3. It is showing a relationship similar to group 2. Group 2 magnesium bicarbonate is similar to this one. So group 2 carbonates and lithium, group 2 bicarbonates and lithium bicarbonates, you can't find them in solution, solid state. They are existing in aqueous state. Okay. So then aqueous state at room temperature, that is correct. At aqueous state, if you heat it or boil it, it will simply give you lithium carbonate white precipitate and carbon dioxide gas and water. So anyway, fourth statement is correct. Fifth one, some of their sulfates are insoluble in water. Yes, some of them. That is correct. So you can say barium sulfate, calcium, strontium sulfate, those are kind of insoluble. Calcium sulfate is also partially soluble. So these are the insoluble ones. Okay. Solubility is low. Insoluble is better for barium sulfate. Okay, now go to the MCQ 15. It's about a structure, Lewis structure. Supposed to be a easy question. Yeah, in the earlier question, put a white precipitate is barium sulfate. Okay, earlier question. Okay, now go to this one. Which one of the following is most stable resonance structure of SO4? Now, the most stable resonance structure. If you check the structures, I'll tell you simply. Right in front of the second one, Pute, it is having a 2+ charge for oxygen. So bearing a positive charge on oxygen is making it less stable. I mean, it is making it unstable. See? So second answer, then third answer, then if you go to the fourth answer, fifth answer, they all contain a positive charge on oxygen. Understand? So right, existing positive charge on more electronegative atom is unstable. So in the first answer, you don't have any positive charge on oxygen. It has a higher charge distribution, but the most stable structure out of the following is this first one. The first one. But can we draw a better structure? Yes, of course we can draw a better structure than this. Okay, first one is good, but this structure is somewhat better. Having a double bond. This one. Then say this is the most stable structure. Most stable. Is it the most stable structure? No, ne? So we can draw another one, right? No. We can't put multiple bonds. Ne? Yeah, that is the most stable structure. Understood? So try others, it will be unstable. But from the given ones, Lamai, first answer is the better answer. Can it? Others are having positive charges on oxygen. So then, right, it is unstable. So more electronegative element should give at least a neutral charge. If there is a charge, unavoidable charge, you can keep that negative. If it is a negative charge, you can keep that one on the more electronegative atom. But if there are no charges in the molecule, giving it a positive charge is making it very unstable. So the one who likes more electrons should have electrons. It should not be lack of electrons. So that's why it is wrong. Okay, so all answers are wrong except the first one. First one is our answer. Okay, Lam. So it's a good MCQ. Write a very good review for this only. And the 16th one is coming from IUPAC nomenclature of D block complexes. IUPAC nomenclature of D block complexes. Let's give it a try. The IUPAC name of this compound. Let's write it in the board. CO CN4 NH3 2 and 2 minus charge is there. Okay. So we need the IUPAC name of this. Right? And first of all, let's find out the oxidation number. Let's say the oxidation number is X. Here is -1 into 4 plus 0 equals to -2. This is a neutral ligand. Then if you simplify, x minus 4 equal to minus 2. Then x equal plus 2. So oxidation number of cobalt is plus 2. So then answers that contain 3, you can eliminate. So therefore answer 1, answer 3 are wrong. Okay, so then select the answer from 2, 4 and 5. So you are writing the ligands first. So it is going to be diamine. Diamine. So is it starting from tetracyanide, that part? Then therefore fourth one is also wrong. Sorry, fifth one is also wrong. Then diamine, then it is tetra, don't leave in space. Tetracyanide. Tetracyanide. So the second answer is telling tetracyano. Therefore, second answer is also wrong. Understood? So you are left with the fourth answer. Fourth answer is correct. Tetracyanide cobaltate, because it is an anion. Cobaltate 2 space ion. Answer 4 is the correct one. Okay, Lama, it's a good question, no? Because the same name is there with cobaltate 3. The same name is there by changing the 3. So some students I saw had selected that answer also. That's why I said, Lama, these questions are not easy. හොඳේ දැන් ඔයගලන්ට ලේසි පේපර් බොරුවට දීලා හරිද බොරුවට හිත සතු කරලා වැඩක් නැහැ ඔයගලන්ටත් නැහැ මටත් නැහැ තේරුණාද ඉතින් මෙහෙම එකක් ලියන්න ලියද්දී ඔයා දන්නවා මේකේ අනික ඩිස්කෂන් එකක් හොඳට කරොත් ළමයි basically we can revise most of the things relevant for the lesson, so it's very valuable. Alright, then we will try to score in these papers. Now even for these papers there are students who got more than 80, more than 75, so that means they are really good. They are going to write an exam level question paper, they will definitely score around 90s. So in the okay, most of the students are having average marks, so 50s, 40s, 60s වගේ තමයි තියෙන එක range එක. ගොඩාක් අඩු අයත් නේ. ගොඩාක් වැඩි අයත් අඩුයි. ඉන්නේ මැද. Okay, so try to improve that mark. Okay, some are doing that one. Most important thing is participating for the exams. Then we class එකට ඉන්න අය නම් හැමෝම ඇවිල්ලා paper එක ලියනවා මම දන්නවා. But some students are there and still don't participating. So for them, the first goal is participate in the exam. Then you can think about improving the marks. Right? So now you all have taken one step further. Now you are participating in the class. That's better. The paper. So then try to improve your marks one by one. For that, today the only part is studying these questions. Think about why you got wrong in that place. Then study more about that topic. Nomenclature එක වැරදුනා කියලා. So find the reason why you got wrong and study that nomenclature part once again. ඒක තමයි කරන්න තියෙන්නේ. That's the only way to improve our marks. Okay, I hope you understand that and do what is necessary. Okay, right, next let's go to the question number 70. It's a question from enthalpy. Standard enthalpy change of combustion of carbon. Now they have given certain enthalpy changes. I'll put them in the board. Standard enthalpy change of combustion of carbon. Carbon graphite solid. Combustion is reacting with excess oxygen. It's going to give you carbon dioxide. Okay. And then they have given formation enthalpies of these CH4 and those. Formation enthalpies of C2H4. That means 2 carbon graphite solid reacts with 2 hydrogen gas to give 1 mole of C2H4 gas. Okay, and that this value is minus 393.5. This value is minus 84. And the formation value of H2O gas, sorry, H2O liquid, H2O liquid, that means H2 gas and half O2 gas, and H2O liquid, they have given minus 285.8. So according to me, Lamai, this question has a very good meaning. Okay, something for you all to understand. Okay, now listen to what I am telling here. Alright? Now, if I ask you to write formation of carbon dioxide, you are going to write the same equation, right? So that means for carbon, combustion of carbon is equal to formation of carbon dioxide, because you are writing the same equation. Right? But that one is not true for C2H4, because C2H4 formation is this one. C2H4 combustion is something else. Okay, combustion is something else, a totally different one. Combustion, you are writing C2, you are taking C2H4. Okay, combustion of CH4 is, it's different. C2H4 comes to this side. So anyway, it is going to give you, I think they're asking that, combustion interval. So I'll write it later. It is different. But for this one, again, you can say formation of H2O is equal to combustion of H2. H2 is equal to formation of H2O. So like that, there are certain things that are worth remembering. Okay, now remember them from this MCQ. Because they are asking about the combustion enthalpy change of C2H4. If I am correct. Yeah, C2H4 combustion enthalpy change. So C2H4 take 1 mole of this compound and it reacts with excess oxygen to form 2 carbon dioxide gas and 2 water, 2 liquid water. And here you need 3 O2. So this is the combustion. So we need this enthalpy change. Okay, to find that, now you can use all these formation data. Use this data, and they have told you it is combustion, but it is equal to formation of CO2. Use that formation data, because why I am telling you that one, Lamai, if you know the formation enthalpies, there is a shortcut. 2 carbon graphite solid and 2 H2 gas, and with 3 O2 gas, you can make a nice thermochemical cycle. Once you know the formation enthalpies, isn't it? That's easier. That's why you can get a thermochemical cycle also without going to any short methods. But it is time consuming. This question is given to think like this. Think, first of all, carbon combustion is equal to carbon dioxide formation. And then you have a bunch of formation data and use them to this formula. Or if you want, you can write delta H naught Rxn equals sigma delta H standard F products minus sigma delta H standard F of reactants. This also you can use. Same thing. Okay, anyway, C2H4 minus 84. 2 carbon dioxide minus 393.5 into 2. And 2 water minus 285.8 into 2. Okay, so if you apply the Hess's law, addition of these two will be equal to addition of these two. Okay, 393.787 minus and 285, 560, 570, 571.6 negative. The twice of this 56. 11.6. Yeah. And then at this edit, Okay, and then this will become a positive answer. So subtract 84. Subtract 84. This is a positive answer. And 13 minus 8. Sorry, 15 minus 8. 7. 1274.6. Answer is answer 2. I saw some of you got this answer correctly. Understood that one? That's a very important point. It's not true for everything. Combustion of some elements is equal to formation of the oxide. Carbon dioxide, water are good examples. Now let's go to the question number 18. Question number 18. Question number 18 is another small chemical calculation. See that one, Lama? Calculate the number of moles of phosphoric acid required to react with 25.65 of barium hydroxide. So barium hydroxide and phosphoric, H3PO4. Okay, so they react to form barium phosphate. Like this is the way you write the formula. Ba3PO4 twice. So how do we get that formula? Ba2 plus and PO4 3 minus. So they have valencies like this. So exchange that valencies and you will get this formula. Okay. And to balance it, you need 3 and 2 and finally 6 water. So from this you can see they are reacting in 3:2 ratio. So first of all, find out how many moles of barium hydroxide is there. For that, we need molar mass of barium hydroxide. Barium is 137. OH is 17. 17 times 4, 34. Oxygen 16, hydrogen 1. So 1 OH group is 17. 17 times 2, 34. So it's 1, 7 and 207. Sorry, 171. And to find the moles, 25.65. You need to divide this one by 171. So for 256, you have 1. 171. So 5. 25 minus, 15 minus 7, you have 8. 8. Then 855. 17 times 5 is 85 only. 17 times 5, 85. So it is related, ne? So it's 5 times. You get 855. So it is 0.15 moles. Now they are asking the number of moles of what? Phosphoric acid. So moles of H3PO4. Okay. So here it is very simple. If this one is 0.15, this one is going to be what? 3:2 ratio, 0.10. So to get that one, Lamai, divide by on stoichiometry 3, multiply by the required stoichiometry, 0.10. Answer is 4. Okay, so that's a kind of a simple question, but still you need to simplify it. You need to balance it. So there you have a small challenge of right now. Let's go to the next MCQ. Question number 19. Question number 19. So they have given you a reaction. Hg2Cl2 reacts with 2NH3 to form HgNH2Cl mercury and NH4 plus and then Cl minus. So there are multiple products. And first of all, think about the oxidation numbers. Now here, Lamai, you have Hg2 2 plus, no? Mercurous. Okay, mercury plus 1 oxidation state. So it is having plus 1 oxidation state. And here you have mercury in 0 oxidation state. That means it has undergone reduction. And here, this one is very important to understand. What is this NH2 and Cl? Hg, NH2 and Cl. So here, Lamai, this is an ionic compound. Here you have Cl minus. Here you have NH2 minus. So therefore, this must be Hg2 plus. Understood? So that means it is having plus 2 oxidation state. So from minus 1 to plus 2, plus 1 to plus 2, it has undergone oxidation. So this is a very good example for disproportionation. Same entity undergo oxidation and reduction. Understand? So understanding this will help you to get the answer. Now Cl minus have been oxidized is wrong, Lamai. In both sides, chlorine is having minus 1 oxidation state. Second one, some nitrogen atoms in NH3 has undergone oxidation. No, nothing has happened. In NH2 minus and NH3, nitrogen is having the same oxidation number, -3. Okay, -3. So it's not going to be changed. All nitrogen atoms in ammonia is oxidized. It is wrong. Like I said in the earlier statement, say in both sides, nitrogen oxidation number is -3. And the next question, this reaction is not 10, that's also wrong. So that means our fifth one, final statement should be correct. So let's look at that one. It says mercury 1, that means plus 1 oxidation number, undergoes oxidation and reduction. That is the correct statement. How many of you got that answer? It's a good MC. Okay, so that undergo both oxidation and reduction. So right there, a disproportionation. Okay. Okay, Lama, good. Now let's go to the question number 20. Question number 20. Okay, so we will finish the today's discussion from this MCQ, question number 20. Okay. Urea can be produced by the reaction between NH3 and CO2. The unbalanced equation for the above reaction, is given here. Okay, now let's give that equation. NH3 reacts with carbon dioxide to form CONH2 twice and water. So to balance this one, you need to add 2 NH3. That's it. It is balanced. Right? So then they react in 2:1:1:1 ratio. Right. Then they're asking the theoretical mass that you can obtain when you allow this amount of grams, 85 grams of ammonia, and then 176 grams of carbon dioxide. So it's not going to be a difficult one, Lama. It will be simple. First of all, find the molar masses of these two gases and then go for moles. Now, molar mass of NH3, nitrogen 14, hydrogen 3, so 17 gram per mole. And then number of moles of NH3, 85 divided by 17. It's divisible. You have 5 moles. 5 moles. Right? And then this one is 176. So molar mass of carbon dioxide. You know it is 44 gram per mole. And then divide that 176 from 44. Okay. So 44, yes. 4 moles. Normally they are giving it to be divided. So these are the added moles. So now again, it's a limiting reactant question. Now to react with 1 of this, you need 2 of this. So to react with 4 of this, you will need 8 of this. So we don't have 8. So therefore, ammonia is the limiting reactant. So to react with 5 of ammonia, how much carbon dioxide is needed? So you can divide 5 by 2 and multiply by 1. So this is half. So you will need only 2.5, but you have 2.5. So this is the ratio that's going to be working. Understood? This ratio is not going to work because 8 moles of ammonia is not there. Understood, Lama? So then the reacted one will be here. All 5 is reacting. With that, 2.5 of this one will react. And here, 2.5 of moles of this one will be formed. Ammonia, urea. Understood? So then that is enough to our question, but anyway, we will complete it. That reacted, the last row is remaining. Here 1.5 is remaining, 2.5 is formed, and 2.5 of water is also formed. So this is the value we need. Then to get the theoretical mass, we need to find the molar mass of urea. So capital M of urea. So you have a carbon atom, oxygen atom, and 2 nitrogen atoms and 4 hydrogen atoms. So if you add them, you will get 60 gram per mole. Then to find the mass, multiply that one by molar mass. So 2.5 multiplied by 60. 2.5 is 5 over 2D. 13. 150 grams. Now it is given in kilograms. So if you divide it by 1000, you will get 0.15 kilograms. Understood, Lama? That's the answer for that MCQ. Okay, so practice like that. So we discussed 13 MCQs today. Sorry, 14 MCQs today. Go through them and study them really well. And in our next paper class, I will try to do another paper class within this week because we missed several classes and we need to give the next monthly test also. Before that, we need to finish this discussion. And I'll try to allocate a date, another date. So my advice is, Lamai, so repeat these questions only. These are really good questions. Allocate some time to study them and go through the marking scheme once you get the paper. Once you get the paper, we will discuss structured essays and essays. Hopefully next week we can start that. And before that, to finish MCQs, I'll try to allocate another session. Okay, we have 10 MCQs to discuss. Right. So study this topic well. Okay, next monthly test will be held around the 12th. I'm hoping to keep it June 12th. Okay. So I'll update you with the more information. But more importantly, very good reading. Okay, study. Okay, Lamai, so good night. Study well. See you again next day. Okay? If you have any further doubts, please send them to my WhatsApp. Okay.